On August 27, 1883, at precisely 10:02 in the morning, a blast detonated in the Sunda Strait. The sound was heard clearly on Rodriguez Island in the Indian Ocean, nearly 3,000 miles from the island of Krakatoa. Chief Magistrate James McNair recorded in his official log what sounded like distant heavy artillery fire from an approaching naval fleet. Yet no ships appeared on the horizon, because the sound had crossed nearly 5,000 kilometers of open sea. 40 miles from the erupting volcano, sailors aboard the British merchant ship Norham Castle suffered shattered eardrums. Captain Lindemann wrote in his logbook that more than half his crew had their hearing permanently damaged by the sound pressure. Across the Australian continent, residents in Perth and Alice Springs rushed into the streets, believing a nearby gunpowder facility had exploded. The acoustic wave had travelled 2,200 miles across arid desert without losing its startling clarity. Modern acoustical mapping confirms that this audible wave spanned 1/13 of the entire surface of the globe. It remains the furthest distance a sound has ever been directly heard by human ears in all of recorded human history. Colonial garrisons in Mauritius, Diego Garcia, and South Australia ordered troops to arms, believing hostile ironclad warships were bombarding their shorelines. Thousands of miles from the eruption, military commanders prepared for coastal invasions that were entirely imaginary. In central India, residents reported distant thumps like heavy timber falling on stone floors. Reports flooded colonial administration offices from over 50 distinct geographic regions, all describing the same mysterious rhythmic booming coming from across the horizon. Yet across the northern hemisphere, cities like London, Paris, and Berlin remained completely quiet. No human ear in Europe heard a single sound from the loudest detonation humanity had ever documented, creating a strange global paradox. 3 months before the catastrophic explosion, on May 20, 1883, the German warship Elizabeth spotted a massive ash cloud. Rising 7 miles above the peak of Powhatan, the volcano had awakened after 2 centuries of slumber. Throughout June and July, commercial merchant vessels navigating the busy Sunda Strait reported vast floating fields of pumice stone. The ocean's surface was choked with porous volcanic rock, forcing ships to plow through miles of thick grey debris. Excursion steamships carried curious sightseers from Batavia to watch the island vent spew glowing embers into the night sky. Spectators treated the growing volcanic unrest as a thrilling weekend tourist spectacle, unaware of the immense pressures building underground. Krakatoa was an uninhabited island complex comprising 3 connected volcanic peaks named Rakata, Danan, and Powhatan. Beneath these mountains, an enormous magma chamber was slowly fracturing, allowing cold ocean water to seep into the superheated chamber. The global telegraph network was in its infancy, but underwater copper cables linked Java directly to Australia and Europe. Operators transmitted routine commercial updates, oblivious to the geological disaster preparing to rupture the seafloor beneath their feet. By August 26, the ongoing eruptions intensified into a continuous acoustic roar that rattled glass windows 50 miles away in Batavia. Falling ash turned midday into pitch blackness, forcing telegraph operators to work beneath flickering kerosene lamps. Late that evening, the submarine telegraph cable linking Batavia to Singapore suddenly snapped under massive underwater landslides. The island of Java was abruptly severed from global communication just hours before the eruption reached its terrifying climax. Ships caught in the strait reported relentless displays of St. Elmo's fire dancing across their wooden masts. Electrical static charged the air as miles of volcanic ash rubbed together, illuminating the pitch-black sky with ghostly static discharges. The ultimate cataclysm occurred on the morning of August 27 when 2/3 of Krakatoa collapsed beneath the waves. Seawater rushed into the exposed magma chamber, triggering a series of 4 titanic phreatomagmatic explosions that shattered the island. The third blast at 10:02 in the morning generated an energy release equivalent to 200 megatons of TNT. This energy was 4 times greater than Tsar Bomba, the most powerful nuclear weapon ever detonated by human hands. At the epicenter, scientists estimate the sound pressure reached 310 decibels. Because normal atmospheric air cannot transmit sound waves above 194 decibels, the blast became a moving wall of compressed air. Superheated pyroclastic flows raced across 25 miles of open ocean, moving at hundreds of miles per hour. The incandescent gas clouds retained enough lethal heat to burn hundreds of people along the southern coast of Sumatra. Collapsing volcanic structures displaced billions of tons of water, generating megatsunamis over 100 feet high. These catastrophic waves swept coastal Java and Sumatra, completely erasing thriving maritime towns like Merak and Teluk Betung. Official Dutch colonial logs recorded 36,417 deaths, though modern historians estimate far higher numbers. More than 90% of these casualties were drowned by the relentless impact of the tsunamis. The immense atmospheric shockwave expanded outward from the Sunda Strait at 700 miles per hour. It compressed air molecules with such violent density that it altered local barometric pressure across every continent on Earth. Atmospheric shockwave smashed timber structures miles away and tore roof tiles from houses across the East Indies. The sheer physical displacement of air pushed weather patterns into chaos, driving sudden localized gales across the Indian Ocean. Popular retellings often claim Europe heard nothing simply because it was 7,000 miles away from the explosion. However, the physical mechanics of sound propagation reveal a far more complex acoustic phenomenon taking place in air. As sound travels through atmosphere, higher audio frequencies lose energy rapidly due to molecular relaxation of nitrogen and oxygen. Audible pitch weakens over distance, stripping away treble and mid-range frequencies within a few hundred miles. By the time the acoustic wave traveled 3,000 miles, every audible frequency above 20 Hz had fully dissipated. Human ears in London could never hear the sound, no matter how immense the original blast had been. What survived across thousands of miles was infrasound, pressure oscillations cycling below human auditory thresholds. These low-frequency pressure waves moved quietly across oceans and continents, completely imperceptible to the human nervous system. Stratospheric temperature inversions acted as a physical waveguide, trapping infrasound between layers of warm and cold air. This trapped channel prevented acoustic energy from scattering into space, allowing the pressure wave to travel vast distances. Though citizens in London walked through silent streets, scientific instruments recorded the invisible arrival. Mercury barographs at the Royal Observatory in Greenwich began recording violent barometric fluctuations precisely 10 hours after the explosion. Self-registering barometers across Europe logged the shockwave passing through every 34 hours. Precision instruments tracked the invisible wave circling the entire planet 3 to 4 times in each direction before finally fading away. The barometric data proved that while human ears are blind to low-frequency waves, Earth's atmosphere was ringing like a giant bell. Europe was not spared the shockwave, its people were simply deaf to its frequency. In 1884, the Royal Society of London established the Krakatoa Committee to gather global barometric, oceanic, and optical datasets. Their monumental publication transformed meteorology from local observation into a rigorous, global atmospheric science. The explosion injected tens of millions of tons of sulfur dioxide high into the stratosphere. Fine aerosol clouds spread across the planet, reflecting sunlight and creating blood-red twilights visible across Europe and North America for years. In Norway, artist Edvard Munch witnessed one of these vivid blood-red sunsets above the Oslo fjord. Decades later, he credited that terrifying sky as the direct inspiration for his famous expressionist masterpiece, The Scream. Suspended volcanic aerosols in the upper atmosphere reduced global surface temperatures by 1.2 degrees Celsius over the following year. Disrupted weather patterns caused abnormal rainfall and widespread crop failures across multiple continents. By tracking the precise speed and direction of ash clouds moving around the equator, meteorologists discovered high-altitude atmospheric currents. This provided humanity with its first concrete proof of jet streams flowing through the stratosphere. Where 3 lush volcanic peaks once stood, a vast submarine caldera sank 300 meters below sea level. The eruption completely erased 2/3 of the original island, leaving behind a shattered, quiet bay in the strait. Deep beneath the ocean surface, volcanic activity resumed in 1927, giving birth to a new volcanic island named Krakatoa. That child of Krakatoa continues to grow 6 meters taller every year from the submerged floor. High above that smoking island, the same atmospheric layers still flow, carrying silent low-frequency vibrations around the globe. The sound of Krakatoa was never truly silent, it was merely vibrating at a pitch human ears could not hear.